Hi, welcome to Physics 5.2 on work and power. You will need your formula sheet for today's video. Work. Key question on work is, when do you actually do work? Well, work in physics has a very specific meaning. Work represents a measurable change in a system caused by a force. So when you push on a wall and the wall does not move, no work was actually done. It may have taken effort on your part, but no scientific work was done. If you push the wall and the wall does move even a little, you've done work. If you push a box with force of 1 Newton for a distance of 1 meter, you have done exactly 1 joule of work. Work is force parallel to distance. So on your formula sheet, add the formula for work. W is equal to F times D, where the W is work measured in joules, F is force measured in newtons, and D is distance measured in meters. In order for work to be done against gravity, we would use a similar formula. Work in joules, mass in kilograms, gravity in meters per second squared, and height, the object was raised, in meters. It's still the same formula, but instead of horizontal, force equals mass times acceleration, we have a vertical mass times gravity. So why the pattern doesn't matter. Notice that as the motion, the motion goes back and forth up the stairs, but the actual height doesn't change. So the motion in the direction of gravity is what matters. So calculate the work done against gravity. A crane lifts a steel beam with a mass of 1,500 kilograms. Calculate how much work is done against gravity if the beam is lifted 50 meters in the air. Then, how much time does it take to lift the beam if the motor of the crane can do 10,000 joules of work per second? Here's a diagram that might help. Power is the second topic, and the key question for power is, how powerful are you? Meaning, how fast can you do things? Power is how fast you're able to do things. So if you start pulling a crate, a 100 Newton crate, 10 meters, if you do it in 10 seconds, 30 seconds, or 60 seconds, the amount of power changes, but the amount of work stays the same. So power is measured in a unit called watts, or another unit you're probably familiar with is horsepower. 1 horsepower is equal to 746 watts. It's the average output of a horse. 1 watt is 1 joule per second, and 1 horsepower is 746 watts. Power is equal to the amount of work done divided by the time it takes to do the work. So power is work divided by time. Again, on your formula sheet, add a box for power. P is power measured in watts. Be very careful with the W's here. W is work measured in joules, and T is time measured in seconds. So if we go back to this example, how much time does it take to lift the beam if the motor in the crane can do 10,000 joules of work per second? That's actually a question about power. Calculating power. If you were going to calculate power to climb the stairs, a 70-kilogram person goes up 5 meters in 30 seconds. So 2 calculations. How much power does the person need to use? And then, how does that compare to a 100-watt light bulb? Another way to express power is a multiple of force and its velocity. If the velocity and force are both vectors in the same direction, power can actually be measured in force times velocity. So P is power in watts, velocity is, or V is velocity in meters per second, and F is force in newtons. That's an alternative equation to calculate power. You're going to be doing lots of problems on work today in class. Next class, you'll be doing questions on power. Thanks for watching.